Hello, today we are going to talk about the topic of acids and bases, focusing on the strength of acids and bases. Strength of acids and bases. What determines the strength of acids and bases? The strength of acids and bases is determined by the extent of ionization in water. The more hydrogen ions or hydroxide ions the acid or base forms in aqueous solution per mole of acid or base in solution, the stronger the acid or base. Strong acids and bases. Strong acids and bases completely ionize in water to form hydrogen ions or hydroxide ions. And some examples are hydrochloric acid and sodium hydroxide. Weak acids and bases. Weak acids and bases partially ionize in water. This means that not all of the acids or bases molecules ionize to form ions in aqueous solution. So the solution of a weak acid or base contains less ions and more molecules than a solution containing a strong acid or base. Here are some examples. Note that both reactions are reversible. Here is ethanoic acid and aqueous ammonia. Here's a little something that can help visualize the strength of an acid or base. For strong acids, here is a beaker and there is hydrogen chloride in it. It is dissolved in it and it's ionized to give all hydrogen ions and chloride ions. Look that all of the particles are completely ionized. All acid molecules ionize in the aqueous solution. For weak acids, here is ethanoic acid and in the solution, and after ionization, only some of them ionize. Most of them remain as molecules. Some acid molecules ionize in aqueous solution and the rest remain as molecules. The strength of an acid or base is directly proportional to the number of hydrogen for acids or hydroxide for bases ions they can produce per mole of acid or base. For example, as seen previously, 1 mole of a weak acid dissolved in aqueous solution does not give 1 mole of hydrogen ions per mole of acid dissolved in aqueous solution. It is not as strong as 1 mole of strong acid that gives us 1 mole of hydrogen ions per mole of acid dissolved in aqueous solution. So the concentration of hydrogen ions in a weak acid is less than the concentration of hydrogen ions in a strong acid. Same goes for bases. The concentration of hydroxide ions in a weak base is not as great as the concentration of hydroxide ions in a strong base. Do note that the concentration of the acid or base does not affect its strength, but instead is only affected by the acid's or base's degree of ionization, based on how many hydrogen ions or hydroxide ions the acid or base can produce per mole of acid or base dissolved in aqueous solution. The stronger the acid, the lower the pH. pH is known as potential hydrogen. The stronger the base, the higher the pH. So here's the equation for finding out the potential hydrogen or pH of a solution. So the pH of a solution is the negative log base 10, or the concentration of hydrogen ions in solution. So do know that the concentration of hydrogen ions in this case is in hydrogen ions, number of moles of hydrogen ions per decimeter cube. Thank you for watching. Do leave a like and remember to subscribe. See you next time. Check out my other videos here.